Hello, great mathematicians, and welcome back to our series on matrices. Today will be our last session on this topic on matrices. So remember, hit the subscription and notification such that we can be updated every time. And please feel free, inbox me, feel free, comment, like. If you have any concern, please you comment. I'll be able to handle the queries with you guys. So today we are going to look at the second method of finding the inverse of a matrix. So the second method of obtaining the inverse of a matrix, we use a concept called the adjoint. And the concept of determinant of a matrix. So this is what we use when we are looking at inverse of a matrix using the second method. We use adjoint and determinant. We are going to see how and why we are doing that. I'm going to start by answering that, why we do that, why we do that. Then we shall go to how, then that will be the application. So let us consider the matrix that we had last time. We are going to look at how are these matrices related. Okay, how are they related? Let us start with the inverse. If I'm to look at the inverse of B, it is equal to 2 negative 3 over 2 negative 3, then 5 over 2. Okay, now if we are to look at this and this, we can create some matrix which is kind of similar to this, but by creating what I'm going to call a useful one. Please, if you feel that the whole of this derivation or how part is not good for you, please jump and go to the how part. How do we apply the formula? I'm going to describe a formula, but if you feel that all what I'm doing here is not important for you, just need how, then please, you are free to jump and go right away to the application. But I would beg, let us move together slowly, we can understand it together. So this one is going to become, if I'm to introduce a useful one here, there's something I want to create. I want to create a matrix which is kind of similar to that. I'm going to have a 2. If I'm to multiply it with a 1, this is a 1. 2 divided by 2, it still goes out, it becomes a 2 still. Then let me leave that one there because I want all of them to have a 2 as the denominator, which is negative 3 over 2. This I multiply by a 2. I also divide by 2. This one already has a 2 as a denominator. I'll have that. Then this matrix here is going to give me, if I'm to pull out a half from every entry here, if I'm to put out a half from every entry, remember when we are talking about multiplication of matrices, we said that we can multiply a matrix by a scalar. So I'm going to form a scalar outside the matrix. So that scalar, I'm going to call it half. If I'm to form that scalar, I'm going to remain with a 4. I pull out a half, I remain with a 4 there. So this is going to be 4. I pull out a half, this is negative 3. I pull out a half, this is negative 6. I pull out a half, this is 5. Okay, now I want you guys to look at this matrix and compare it with the matrix that we are having there. I want you to compare it. Let me use another pen. I want you to compare this matrix with the matrix here. 5, of course, that was a B, and this is B inverse. I want you to compare these two matrices and see, this is 5, 3, 6, 4, and see, is there any relationship? If we are to look at these two matrices critically, apart from the scalar that is multiplying this matrix here, you are going to find that the positions of these two has been interchanged. A 5, this side it was up, now it is down. A 4, it is interchanged. And the sign of these two matrices, I mean of these two entries, has also been interchanged. So these matrices are almost the same. What is different is the signs has been interchanged and the positions also interchanged. So now what we have here, okay, is the adjoint of that matrix. Is it making sense? What I have here is the adjoint of matrix B. And what I have down here, is the determinant of matrix B. So meaning that if I try to find the determinant of this matrix, remember we said the determinant, it is the diagonal, the leading diagonal, that is the product of the leading diagonal minus the product of the minor diagonal. If I try to get the product of the leading diagonal and the product of the minor diagonal, I'm going to have 5 times 4, that is going to give me a 20, minus the product of the minor diagonal, which is 6 times that is going to give me 18, and it will give me a 2. And this 2 is being divided down. So what I'm having here as the inverse, meaning that the inverse of any matrix here is going to be 1 divided by the determinant times the adjoint of that matrix. Hope that is clear for all of you guys. So now we are going to write the definition of the inverse of a matrix using this method, meaning that the inverse of any matrix, is equal to 1 divided by the determinant of that matrix times the adjoint of that matrix. So first of all, you find the adjoint, you find the determinant, then you state this formula and just put in. We are going to do an example on how we can get the adjoint and we get used just, okay? So that is what we shall be doing. Hope that is clear. And to go more general on the adjoint, if I'm to consider a matrix A, the adjoint of this matrix, the adjoint of matrix A is going to give me, you look at the major diagonal and the minor diagonal. The entries in the major diagonal are going to interchange positions. I repeat, the entries in the major diagonal change position, and the entries in the minor diagonal change the sign. So from here, I'm just going to see which entries are in the major diagonal and which entries are in the minor diagonal. So if I'm to look at this, these entries here are in the major diagonal. So they are going to interchange the positions. A goes where D was and D goes where A was. Then the entries in the minor diagonal will change the sign. If this was positive, it becomes negative. If it was negative, it becomes positive. If this was positive, you do the same thing. Meaning that the adjoint of this is going to become, the entries here are going to change the position. The entries here are going to change the sign. This one is the sign. This one changes position. Like that. So the adjoint of that matrix is that. Hope that is clear for you guys. Then I can now get the determinant of matrix A. Remember we said to get the determinant of A, I just get the entries in the major diagonal, that is the product of those entries, minus the product of the entries in the minor diagonal, which is going to be AD minus CB. Now from here, I can restate my formula that inverse of any matrix is 1 over the determinant of that matrix times the adjoint, meaning that now the inverse of A is going to become 1 over the determinant of A times the adjoint of A. Then from there, I can substitute back the values I have, which is 1 over the determinant of A, which is AD minus CB, multiplied by the adjoint of matrix A, which is what we have there as D, negative B, negative C, A. So what you have here, you multiply it back in that matrix. This will be a scalar, of course. You multiply it with the matrix and get the matrix. Hope that is making sense. So let us do an example on that. Example, we want to find the inverse of matrix A, which is given as above. So from here, always, first of all, remember the definition. It will guide you on what you have to find. Okay, remember the definition, which will guide you, meaning that the inverse of A should be 1 over the determinant of A times the adjoint of A. So to get the determinant of A, remember product of major diagonal entries times 2 minus 5 times 3, which is the product of the minor diagonal entries. This one is going to give me 16 minus 15. That's going to be a 1. So the determinant is a 1. Then I get the adjoint, which is going to be, remember adjoint, I told you guys that the entries in the major diagonal change position. 2 comes up and this one becomes 8. Then the entries in the minor diagonal are going to change signs. This one's change sign, this one change position, and this one becomes negative 5. As simple as that. So this is the adjoint of A. You should remember that. This is the adjoint of A, and the other one is the determinant of A. If you don't know the terms that I'm using here, adjoint, I mean diagonal, minor diagonal, major diagonal, please go back and review our videos on terms used when dealing with matrices. You'll find all this content there. So now the inverse of A is going to become 1 over the determinant, which is 1, times the adjoint, which is 2, negative 3, negative 5, 8. Then I multiply this one inside. I'll remain with 2, negative 3, negative 5, 8. What I have here is the inverse of matrix A. As simple as that. So you can choose which method is easy for you guys. The first one, whereby you have to first let the unknowns and solve the equations simultaneously, or this method whereby you have to get the determinant and get the adjoint, then multiply that scalar, the determinant, with the adjoint matrix. Then you find the matrix that is required. It is all up to you guys. If you are not restricted of which method you should use, choose any method. It will be absolutely very okay for the examiner or anyone testing you or your teacher or anyone that is teaching you. Choose what you want, choose what is best for you, choose what is very easy for you. But a great mathematician will choose both, understand them all, but always use the easiest. Clear? Okay, let's do one more example. Okay, now we want to find the inverse of that matrix. Now, if I'm to look at this, let's first of all let this matrix the solution. Let's first of all let this matrix to be any number. Let's let it to be A, to be 39, 91. This one will make our work very easy. Then I'm going to have, remember, inverse is 1 over the determinant of that matrix times the adjoint of that matrix A. Then I get the determinant of A. If I'm to get the determinant of A, I'm going to have 39 times 119 minus 51 times 91. If I'm to get these values here, I'm going to have 4641 minus 4641. Oh my god, this is giving me a 0. We said matrices that have determinant as a 0 are singular matrices. Who recalled that? If you did, you can clap for yourself. These are called singular matrices. They don't have the inverse. Why? You see that if I get this determinant as 0 and divide it here, remember now I'll have A inverse, which is 1 divided by 0, times whatever adjoint I would get this side. You can go ahead and get that adjoint. But the moment you see that the determinant is 0, stop there and say it has no inverse. It is a singular matrix. Because any number divided by 0, these are infinitely many solutions. The calculator, it will give you math error. It will not calculate this value for you because it is not existing. It does not exist. There are many solutions, so it does not exist. It will give you an error. So any number divided by 0, we say it doesn't exist at this level. So this number doesn't exist, meaning that the inverse also doesn't exist. So the moment I find the determinant as 0, there and then I stop. That is the best thing with this method, that so long as you get the determinant as 0, you will not hassle with the equations solving for the unknowns using either elimination, substitution, matrices, or graphical method. So the moment I get the determinant as 0, then it is a singular matrix and the inverse does not exist, or it has no inverse. So from here I'll take this time to note down something for you guys. Let us note it down here that if we are to look back at the first number we did, we got the determinant as 1. Now I'm going to take two things at once. If you get the determinant of a matrix as 1, then the inverse of that matrix will always be the adjoint. That is the first note. The second note is that once you get the determinant of the matrix as 0, then the inverse doesn't exist. It has no inverse. Those are the two things I want you guys to note down for now. Let us do one more example. I'm giving you an example stroke exercise. Given, find Roman 1, Roman 2, Roman 3, and Roman 4. Okay, guys, let's do this and then we can stop. Oh, I said example stroke exercise. Okay, let me just give you a hint, guys. Right? I think that is okay. Yes, you are very good mathematicians who want to always try. Okay, you are going to try it, but since I said example stroke exercise, let me give you a hint. P. To find the P such that AB is equal to P. No one can fail to do that, guys. That is the simple multiplication of matrices. We covered that. So we are doing the example. Then P inverse. The first method, it is okay if you want to use that, but I want you to practice this second method. So after finding this matrix, after forming matrix P, go ahead, use matrix P to find P inverse. Get the determinant of P, get the adjoint of P, then substitute in our formula that P inverse is equal to 1 over the determinant of P times the adjoint of P. of P. You can substitute in that formula and get the answer. Then the second one, this is some simple addition of matrices. Get matrix A, get matrix B, add them, you form one matrix. The matrix you form, it can be any matrix, you can call it Q. So after finding that matrix, maybe you will call it Q if you wish, you can call it Z if you wish. After finding matrix A plus B, which is Q, then find the determinant of Q and also find the adjoint of Q. State the formula and substitute the determinant of the matrix which is formed, and also substituting the adjoint which you have formed, then you'll be able to get the inverse of Q. Then for the last one, the same thing. It is some simple subtraction of matrices which we covered last time, that you subtract two matrices and get the answers. So subtract the matrices, the matrix you form, call it any figure you want. You can call it Z, you can call it Y, you can call it P, you can call it Q, you can call it any figure you want. The matrix you form, which is going to be B minus A, maybe you can call it Z. Then the inverse of Z, of course, that is B minus A, which is Z inverse, is going to be 1 over the determinant of Z multiplied by the adjoint of Z. Then from there, you can get the answers and see what you will have for that matrix. Should I give you the answers that you are going to get? The answers are going to be the first one, for the second one, the third one, then lastly. So these are the answers I expect you guys to have for those questions. If you fail to get these answers, you never know, you may get a different one. When it is the right one, I may have made a mistake. Mistakes are human, okay? But sure that these are the answers that you'll get. If you get a different answer, please comment and we see, okay? And we'll talk about it. Maybe you made a mistake somewhere, then we can correct ourselves and see where you went off. So for today, let us stop here, guys. Thank you very much for watching, and be a great mathematician by practicing mathematics. Thank you. Subscribe, notification.